Hello guys, welcome to the Code to Coffee. Last video we have discussed the subset of string, okay, and we have discussed the recursive approach, okay. Now let's discuss the other that is the backtracking. Okay? Backtracking. Okay, so in backtracking, what we does, let's say we need to find the subset of A, B, C, right? And what will be the subset of A, B, C? That will be empty string A, B, C, A, B, B, C, AC or ABC. So we closely observe. Let's take any character from this string. So let's take the A. Okay. So in this string we don't have A, right? So we are not including A. Here we are including A. Here we are not including A. Here we are not including A. Here we are including A. Here we are not including A. Here we are including A. Here we are including A, right? So so sometime A we are including, sometime we are not including it. Similarly for the any other character, for the B. For the B, we are not including B, we are not including B, here we are including B, and not including B, here including the B, here we are including the B, here we are not including the B, here we are including the B, right? Meaning, this is the same approach we are going to apply in the backtracking. So sometime we will include of characters and sometimes we will not include the character, right? So how we are going to do this? Let's say we need to create the subset of A, B, C, right? So what I'll say, okay, this time I will include the A and whatever the solution I'll get for BC, right? And this other thing will not, I'll not include the A. So only the BC, the solution of the BC, right? Next time I'll say A is already included, right? So it's there. This time B I will include and C the solution of the C, okay? And this time because A is already included, right? So we will keep the A and this time we are not including the B, right? So the only C, right? Similarly here we will include the B and the solution of the C and we will not include the B, so only solution of the C, right? And this time what how we'll do? This time we'll do this, we'll include the C and will not include the C. That's mean it will be empty string, right? Here, here we'll say, okay, B is already included, right? This time we'll include the C and here we are not including the C, but B will be there, right? Which is already included. And here if you say A is already there, so this time only C we will include and this time and the other place we will not include the C. So only A will be there like this. And here A, B which is already there, this time C will include and this time C will not include, then only A, B, right? So if you'll see, let's start with the I equal to 0 and every time we'll keep increasing of the indexes. So I equal to 1, I equal to 2 and I equal to 3. So this is will be our base condition, right? So we can say, okay, our base condition will be something like if I is equal to length of string, right? In that case, we can print of output. And what will be the output? Let's discuss this thing. So we got this I equal to 3 for the all this leaf node, right? So that's mean we will print C, will print B, will print BC, will print A, will print AC, will print AB, will print ABC. So these all are our subset, right? It's exactly the same subset. So this is we are going to do, okay? And the recursive approach, I mean, so the recursive solution will be the output plus the function we'll call, right, recursive function, output plus the character of, character. Character is nothing but the S of I. And other thing will not include the character, right? So the only output. So this is we are going to code. Okay, let's code this one. So we have created the one function called the subset of backtracking, and we'll just pass the string and the starting index is nothing is I, and the output. So initially output will be empty string, right? So let's code this one. First we'll check the base condition, right? Base, and here we'll check if I equal to length of string. In that case, we can just print fmt dot print ln of output, right? And then we can just call recursive call for the subset of bag with the string I plus 1 and the output plus C, which is the character, right? Let's copy. This time we are not including C. And what is the C? C is nothing but S of I, right? So we can write like S of I, like this. Okay, let's print this. I mean, run this code. Okay, here we are getting the error. Okay, so we need to also return. So once we reached at our base condition, we can also return. So let's save it, clear, and run it again. So here you can see all the subset we are getting as expected. Only things we are not getting is the null. So what we can do, we can check if uh, output is equal to empty, right? In that case, we can print null. Let's print this one, and in else condition, you can print the out. Sorry. Right? So now you are printing the null. So what if we want in the array format? Okay, what we can do? We can create one array here. Let me say SS array, that will be array of string. Okay, now array of string. Let's initialize with nothing, and we can pass this reference of this SS array. Okay, because we are passing the reference of SS array, we need to expect that array SS array in a pointer way. Okay, nothing but a string. Similarly, whenever we are calling, we can just call the SS array, and here we can, instead of printing, what we can do, we can append into the SS array. Let me write like this because it's a pointer, so like this, append with the null, and here we can print with the output, and we can append the output, right? Control save, and what we can do, you can just print fmt dot print ln with the SS array, right? Like this. Let's again run it. So yeah, here we are getting the same like this. Instead of saying nothing, we can just simply say with the backtracking. Backtracking. Yes. Okay. So this is what we are doing here. If you observe, every time we are calling two times, right? Here one time, here one time, right? So, and this will go till end, right? So I mean the n. So the complexity will be n and to the power n, because to the power n means two times we are calling for each recursive call, right? So that's why to the power n, and this n is nothing but here we are doing the operation for the each element, right? So the complexity will be order of n. So that's all about this backtracking. Okay, now let's discuss the another approach. We say it the bit masking. Okay, bit masking. Yeah, thank you.